Hello, everybody. Thank you for coming to this talk. It's great to see so many people interested in learning about Java API design. My name is Miro Cupak. I'm with a Canadian company called DNA Stack. And our mission at DNA Stack is to improve lives of people affected by genetic disease. We do that by making a platform for access, search, and analysis of biomedical data. And if health tech is something that you're interested in or curious about, I'm always happy to chat about it. So just come up and talk to me after the talk. Because in this talk, we're not focusing on the domain. We're focusing on the underlying technology stack, which of course is Java, and since version 9. If you haven't seen JShell before, don't worry about it too much. The tool is extremely easy to figure out. So let me just switch to my terminal here, and let's start with the first API, which of course is collections. I hope the font is big enough, by the way. If you can't read it or anything, please let me know, and we'll adjust this. So far, so good? Perfect. All right. So changes in the collections API that we're talking about are from Java 9, 10, and 11. Java 9 and 10 basically improved our use of immutability when it comes to the collections, which was something that was relatively tedious to do with the previous releases of the platform. And I'm sure everybody knows the drill. If I wanted to create, let's say, an immutable set prior to Java 9, I would probably do it like this. Let's just create a new hash set, let's say, of integer, and let's call this a set, and make this an interface. Then I would probably add a couple of elements, let's say 1, 2, 3. And finally, to make it immutable, I would wrap it in collections, unmodifiable set, give it my set from before, and let's just assign this to the same variable. And this works, right? But there are several problems with this approach. First of all, it's pretty verbose. I needed, like 5 lines of code to create a very simple immutable set. That's not ideal, right? This should be a one-liner. And the fact that it's not a one-liner, it's kind of annoying. For example, if you're dealing with static collections, you need to use static initializer blocks, which is not particularly pleasant. This also isn't a truly immutable set. It's more like an immutable view of the underlying set. But if I kept the reference to the original set, I would still be able to modify it, which is why this idiom is very common, right? I wrap it in unmodifiable, and then I assign to the same variable so as to lose the reference. There's also performance overhead associated with this approach. Aside from all the extra objects that I had to create in the process, there's also performance overhead associated with supporting mutability in the underlying collection. So just overall, not the best approach here. And people were unhappy with this for a very long time, so they sort of went out of their way to come up with various workarounds to address some of the issues of this approach. And we've had a few of them, right? One common workaround that people used to use is basically pipe it through some sort of an external data structure. So you could do something like arrays as list, 1, 2, 3. Now, of course, the only method that we have in arrays is asList, right? We don't have asSet or anything like that. So to make it a set, I would actually have to probably use the copy constructor. So I would make it a hash set, and then to make it immutable, I would have to wrap it in collections unmodifiable set again. So something like this. And this works, right? And it helps certainly with the verbosity aspect of things. It's now a one-liner. But it's still kind of verbose in its own way, in that there's a lot going on the same line, right? I'm creating a set from a list through arrays. So not exactly ideal. And otherwise, we're sharing pretty much the same disadvantages of the previous approach, right? It's still not truly immutable, and there's still the performance problem that we had before. Alternatively, we could pipe it through a stream, starting with Java 8, of course. I could do something like this, and then just collect to set. But then there's no guarantee on immutability again, so collections, unmodifiable set, just like this. But again, similar disadvantages, right? It is a one-liner, but still kind of verbose, a lot of things going on the same line, still not truly immutable, still performance overhead, so it doesn't help us that much. And finally, there's this double brace construct, which is a little bit more niche, but you may have seen it before. I could create an unmodifiable set like this, start with unmodifiable set, then create a new hash set of integer, and then I would use the double brace construct, something like this, and inside I can initialize it with the elements that I have here. And this works as well. Again, similar disadvantages, pretty verbose, not truly immutable, and performance overhead as before. In fact, in this case, it costs an extra class at its usage, right? And we're sort of holding references to the enclosing instance, so we're actually also risking memory leaks. So this is definitely not an ideal approach, but it was an option. And finally, we could also use, and that was actually probably the most common option, we could use a third-party library like Apache Commons or Guava to actually get proper immutable collections. So if I wanted to try that, I can just add Guava on my class path, and then I can make an import to the right package, Google common collect, immutable set, and now I should be able to create an immutable set just like this. And this helps a lot, right? This is now very concise. This is a true one-liner. It's truly immutable. It doesn't have the performance overhead. But it requires pulling in an extra dependency into your code, right? And it kind of feels wrong to pull in a whole external library just to get this simple construct. But that's actually what we ended up doing in the past, right? Guava is one of my favorite libraries, and I was doing this all the time. So creating immutable collections in Java used to be hard and traditionally involved a lot of boilerplate. And the trouble and the boilerplate doesn't end here, right? If I wanted to create a copy of this set, like an immutable copy, more specifically a shallow copy where they're sharing elements, I would naturally, this copy, expect to be also immutable, right? Because the original is immutable, but that's not how it works in Java by default. And we've kind of seen it with one of these examples. If I wanted to create a copy of this set, I would probably use the copy constructor. That's the usual way to do it. So I can just give it my set from before, and let's call this set2, and make this an interface again. But now, if I try to add something to this set, you can see that it just goes through, right? In other words, this is mutable. So to make it immutable, I would have to wrap it again in collections unmodifiable set. So again, we're dealing with a lot of boilerplate here. So there's a lot of additional complexity going on with what should be very simple, right? And this boilerplate problem that we have here has two parts. There's creation of immutable collections, and there's creation of immutable copies of collections. Now, Java 9, of course, fixes the first part of the problem, which is creating truly immutable collections. And Java 9 does that by introducing new static factory methods on all the main interfaces, list, set, and map. So if I wanted to take advantage of this functionality, I can just use the method of here. And if we take a look here, you can see that it's overloaded quite a few times, actually, 12 to be exact. So it's 0 to 10 arguments, and then a single var method at the end. And you might be thinking at this point, why are we polluting our API like this, right? Surely the var case captures all the other cases. And that's true. But the reason we're doing it this way is essentially performance, right? There's performance overhead associated with allocating the array to back the var. So if you're creating reasonably small collections, which presumably is the vast majority of use cases, you want to avoid this penalty. So to use this functionality, I can just do something like this, and you're probably noticing that this is very similar to the Guava approach. And this gives me a nice set here, and if I try to add something to it, you can see that it doesn't go through. In other words, this is truly immutable. In fact, if I take a look, at the class here, you can see that it's some immutable set, right? So the interesting thing to note here is that this is not your standard hash set. This is a very special implementation of a set. And the concrete classes returned by these factories are not a part of the public API. So you can only rely on the interfaces here. And on top of that, the only way to obtain them is through static methods on the interfaces, which are not inherited, so you cannot invoke them through an implementing class. Which means that this is pretty much the only way I can obtain such a set. And I just wanted to point this out as sort of a nice design pattern that allows the implementation to change in the future. So that said, the API for a list is basically exactly the same. Again, 12 methods, 0 to 10 arguments, and a single var. For a map, however, it's a little bit different, and you can't see it too well because of how big my font is, but there are only 11 methods here. So it's 0 to 10 arguments, or in this case 20 because you're specifying keys and values one after another. But there's no var method here. And the reason there's no var method here is because keys and values can have different types, and you can't have two varargs in a single method, right? So what they did instead, they actually provided another method here, which is called offEntries, and this takes a single vararg of type map entry. So if I wanted to create a map like this, I can just do something like this, and this gives me a map where key is an integer and value is a string. So that's Java 9, fixing the first part of our boilerplate problem. Java 10 fixes the second part of our boilerplate problem, which is the creation of immutable copies. And Java 10 does that by providing a copy of factory methods on all the main interfaces. So if I wanted to create a copy of my set, I can just call set copy of here, and let's call this set 2. And of course, if I try to add something to this set, you can see that it is already immutable out of the box. And not only that, it is actually pretty flexible. I can use this to convert between different collection types. So if I wanted to have a list, I can just use list, copy of, give it my original set, and this just gives me a list. For a map, it's a little bit different. Of course, maps have keys and values, and we need to deal with that somehow, so we can only convert from another map, but that kind of makes sense. And that's not all, actually. So Java 10 certainly helps with the copying problem, but what they also added is they introduced collectors to immutable collections. So you can now use immutable collections properly with streams, which is kind of the last missing piece where you weren't able to do that. So if I obtain a stream, I can just call the method collect, and I can use toUnmodifiable set, for example, and now I get an immutable set right from my stream. So nice and easy, good thing happening here. So what this basically means is that starting with Java 10, we can use immutable collections everywhere. And you should take advantage of this, right? It's a good practice to create immutable things by default and only add mutability when it's really needed, which is not what people traditionally used to do in Java, right? People would just create regular collections because it was just so hard to do. So that's Java 10. Collections play a little bit better with streams. Java 11 extended collections as well, and we made them play a little bit nicer with arrays. And Java 11 does that by introducing a toArray method, which is actually a default method on the collection interface, so it's automatically inherited by all the collections. And if we take a look here, you can see that there are 3 versions of it. So the last 2 were available prior to Java 11. The first one is what was added in Java 11, and that's the most flexible one. You can see that it basically allows you to convert an array to a collection using a generator function. So what this means, for example, is that I can just use a quick constructor reference, which is obviously a very common construct. Maybe we don't see it very frequently with arrays, but it works just fine. So I can, for example, create an array using this very concise syntax. And it's just a little bit nicer, a little bit cleaner, and a little bit more flexible. And a little bit better for consistency as well, because we had this kind of method in the stream API, so it's just nice to have it in the collection API as well. And it's a pretty useful method, right? There are still times when we need to convert between the arrays and collections, and now we have a convenient way of doing so. So, to recap, what are some of the best practices that we've observed when it comes to the additions to the collections API? Well, we now have convenience factory methods for both creating collections directly and by copying. And this approach not only leads to truly immutable collections with good performance, but it's also less verbose and doesn't require static initializer blocks. We should make collections immutable by default and only add mutability when needed. This is good because we don't have to worry about leaving behind references to the underlying collections. And the approach is thread safe, right? Which means that our collections can be shared freely, no need to make defensive copies and things like that. And performance is better too. No need to support mutability in the underlying collection. Also remember that this applies to streams as well. We now have collectors to immutable collections. And finally, remember that if you need to convert a collection to an array, you can now use the new toArray method from the collection interface. Now let's recap some anti-patterns that we've observed, so things that you shouldn't do. Basically, don't use the legacy workarounds for making the old-school collection and creation approach a one-liner. Right? Don't obtain collections by piping data through arrays as list or stream off. Don't pull in external dependencies only to obtain immutable collections. All this has been superseded by the new factory methods. And especially don't use the instance initializer construct in an anonymous inner class. It's not readable, and you're risking memory leaks. Finally, be careful about prioritizing performance over cleanliness of your APIs. Remember the large overloading of the auth method on all the main collection interfaces, right? Of course, what they did and why they did it was good. This is one of those rare cases where you have a massively used API where any small performance decrease is unacceptable. But in general, I would say this is an anti-pattern, right? Your API is most likely not in the same situation as the collections API. So you probably want to favor cleanliness, readability, and maintainability over performance at the API level. So just think carefully about making the opposite decision. So those were anti-patterns. How about some patterns, things that we should do? Well, we've seen the pattern of using static factory methods to create objects, right? Of entries and copy of. And that's a good pattern overall, right? And often better than using constructor directly. Because it allows you to name the methods. The constructor has a fixed name. And if you have several methods that create objects in different ways, you can distinguish between them easily. Just name them differently and avoid overusing the constructors. Also note the concise naming of these factory methods too, particularly the word of. It's a convention in Java to name static factory methods that way. Of is a good name, and you will find of methods in many different APIs across the JDKs, so it's a good convention to use in your own code as well. Remember the situation where we had immutable implementations of collections, but the concrete classes were not a part of the public API, and the only way to obtain them was through static factory methods on the interfaces returning their instances. This is a nice design pattern to enable the implementation to change in the future. Don't be afraid of static imports. It's a good practice to perform them, provided they don't reduce readability, as is the case of map entry. So nice little trick there. And also note the trick that we used with map of entries, right? We needed multiple varargs, which was not possible, so we used a wrapper object, map entry, and we created this convenience method to generate it, which was also called entry. Remember that you can use copy of to not only create copies, but also convert between different collection types. That can also be useful. And remember the pattern of using reference to a constructor in place of a generating function. In our case, we use that to create arrays with very compact syntax. And last but not least, and this is an important one, it's a good practice to create immutable objects by default, pretty much universally, and now it's easy to do with collections, including when we're creating their copies and collecting in streams. So this brings us to the second API on the list, which is StackWalker. So StackWalker is essentially an API for easy, lazy, and stream-friendly access to stack traces. So before Java 9, we had the old getStackTrace API, which has been available since Java 1.4, right? So what I could do before is create a throwable, and then I could call the getStackTrace method there, which returns an array of stack trace elements. Alternatively, I could obtain a reference to my thread and call getStackTrace there, which gives me the same output. So this is my stack trace at this point in time. So there are a couple of issues with this approach, right? First of all, it's very expensive. The JVM needs to eagerly capture a snapshot of the entire stack, even when you only need the first few frames. So basically so that it's able to consistently represent it in an array. There's no easy way to filter these, right? You basically have to go for all the items, even the ones that you're not interested in. And you cannot access the actual class instances of the classes declaring the methods. Everything is a string here, right? And on top of that, there's not even a guarantee that you're seeing the entire stack trace. The specification actually says that the JVM is allowed to omit certain elements for performance. So overall, not a great approach, but thankfully the new StackWalker API fixes all of that. So the new API is built around a class called StackWalker, and I can use that class to obtain a StackWalker instance, and then I can call the main method there, which is the method walk, and here, inside the walk method, I can basically access stack traces as streams. So I can do, for example, something like this, to list, and this actually gives me, and I forgot a bracket, this actually gives me a list of stack frames, right? I don't need that right now, so I can just do this, and you can see that the output of this is pretty similar to the one that I got from getStackTrace. So one thing to note here is that the walk method does not produce a stream, right? It takes a function on a stream, so you can sort of use streams internally within the method rather than on top of it, which would be a more common approach. This is important, and we'll talk about why. But I can do a lot more with this thanks to the Stream API. For example, if I wanted to see the stack of depth 3, all I need to do is basically take advantage of standard Stream API functionality. I can just do limit 3, And these are the top 3 elements of my stack. Similarly, I can, for example, get access to the classes declaring the methods. All I need to do is tell the StackWalker to retain class references through an option here. So I can just say retain class references. And then I'm going to remove this limit here, but I can keep using the stream API. I can extract this information using a map. So for each frame, give me the declaring class. And now this is the list of classes participating in my stack. So nice, a little API there can be useful in many situations. So let's recap. What are some best practices that we've observed? Well, with StackWalker, you can now take advantage of the stream API to lazily access only certain elements of the stack, right? Be aware that there are configuration options available. We've seen the one that allows you to retain class references, so don't resolve classes manually by name. But there are other options as well. You can, for example, show hidden or reflection frames. In terms of anti-patterns, don't use the old getStackTrace method when doing any processing on the stack, essentially. There is a time and place for this method, of course, such as when you're throwing an unrecoverable error. But more often than not, you should probably use StackWalker instead, especially when you're doing any processing on the stack. Don't treat the stack as text, which is what the old approach did. Use a better structure, like the new approach does. In particular, don't use strings to represent class instances. Don't eagerly access whole things when you only need parts of them, which is one of the main issues with the old getStackTrace. And avoid hidden behavior, right? Your API should be clear. Remember the omitting of certain elements for performance reasons. That should be clear from the API contract. As for the patterns, let's think about why the StackWalker API feels so pleasant to use. So we're using collections and streams instead of arrays, like the old approach did, right? That's obviously very nice. Related to that, choose the right data structures and object representations in general. In particular, it can be sometimes tempting to model things as strings because they're easy to deal with consistently from your perspective as the provider of the API, but that can make things hard for the consumer of your API because then they need to deal with appropriate conversions or lookups or whatever you have. And this is a major problem with the old approach. Improve performance by utilizing lazy access to elements through streams. We saw an interesting pattern of a method, the method walk, which was accepting a function on streams as a parameter rather than returning a stream so that you could chain things onto it yourself. And this was done to maintain consistent state and control, right? You need to have a consistent view of the stack. So this is a good pattern if you want to use streams, but you need to maintain such consistency. We also saw the pattern of obtaining configured instances through static factory methods, parameterized with enums, right? In our case, it was the getInstance method with an optional option parameter. That's a very generalizable pattern as well. And we haven't talked about it too much, but the StackWalker API actually works when running with a security manager too, so the access to class objects in stack frames doesn't compromise security. There's even a performance optimization. Permission checks are done sort of at startup when you're constructing an object rather than using it. So that's a good pattern as well, potentially something to keep in mind, depending on what kind of stuff you work on. Most of us probably don't have to worry about the security manager. And this brings us to the third part of the talk, which is the process API. In my opinion, the process API is one of the most underrated features introduced in Java 9. I was actually really excited to see it because I personally felt the pain of dealing with this, in the absence of this API. And it primarily provides us with a new way of getting information about processes. So if I go back to my JShell here, we can just start by sort of thinking about what we had available before, right? One thing that we had since Java 1.5 was the old process builder API, right? And that API allowed us to launch native processes. So since Java 5, I could do something like this. I could create a new process builder. I can give it a command. Let's say I want to list all the Java processes running in my operating system. I can just give it JPS. And this starts an external process. And this was good, right? But the main problem of the Process Builder API is that it was very limited, especially when it comes to obtaining information about processes. There was no clean way to do even very simple things, such as obtaining the PID of the process. Of course, it's available now, but it wasn't available at the time it was introduced. So what people ended up doing for things like this is either do it through JMX, which is very hacky, or they would write their own tools, which often involved sort of calling operating system utilities to obtain information about the process from the outside. So you might call something like PS and grab, and that's how you would obtain information about the process. But that's just unnecessary. It's not something you should be doing. And it's actually really hard to do in a portable way if you have some sort of a portability requirement across platforms. And this is important to have nowadays, right? In today's polyglot world, we have tons of automation tools that need to deal with processes and programs written in different programming languages. You often have microservices that might call a specific tool written in a different programming language. So this is a very useful addition in the JDK. Now, to be fair, there were better alternatives in the past than the raw process builder in the form of third-party libraries, of course. For example, Apache Commons exec is a very common one. So if I wanted to use that, I can just add it on class path here, and then I can perform an import. Don't worry about the errors. That just JShell is just redoing the stuff that I did before. So I can do org Apache Commons exec, and let's just import everything here. And then I can use an executor. Let's just use the default one. And I can use that to execute a command. And to be consistent with the previous example, I'm just going to use command line parse and give it my JPS. And this works just fine, right? And you can see already that it's quite a bit nicer, right? It gives me a reasonable return value. It gives me the output by default, which is very good. And this is actually very flexible as well in terms of dealing with arguments, being able to run asynchronously and stuff like that. There are disadvantages, of course. This requires an external dependency. And whenever you're pulling something external to the JDK, there are portability concerns, even though obviously something like Apache Commons is pretty widely used, so you have reasonable guarantee that it's going to work reasonably well, but there's always that risk. It's also a very old library, so it doesn't play nice with some newer constructs in the JDK. For example, it doesn't do async through completable feature, which is how you should do it nowadays. So that's not great for consistency with the rest of your code and sort of minimizing the surface area of what your developers need to learn and understand. But thankfully, this is now all in the past, and obtaining information about processes is now straightforward thanks to the new API. And the new API is built around a class called ProcessHandle. It's actually not a class, it's an interface. ProcessHandle is an abstraction of a native process. So it allows you to do quite a few things, actually. I can, for example, obtain a handle to my current process, and I can extract all sorts of things, such as a PID. There's a lot more things available through the nested ProcessHandle info interface. You can see there's a bunch of stuff here. And they actually provide convenience methods on this to access each individual piece of this information. So I can do something like command line, and you can see that this is how my JShell process was started. So nice little addition to the API there. You're, of course, not limited to the current process. I can obtain information on all processes. I can just do ProcessHandle all processes. This gives me a stream of all the processes that are visible to me. And I can use all standard stream functionality, for example, a map to extract some information. Let's say for each process, give me info and give me a command. And let's just collect them, let's say, to a list. And this is the list of all the commands running in my operating system right now. Another really common thing to do here is basically this API gives the ability to trigger actions on process termination. So essentially, you can create a listener, and you can implement some handling for when an external process completes, which is a very common thing that people need to do, right? And that's done through the onExit method. So to demonstrate this, let's create a new process. I'll just use the now enhanced process builder API here. I'll give it a command. Let's give it something with predictable runtime. So I'll just give it sleep for 3 seconds. And I can just start this external process. Now, immediately, I can obtain a handle to it, just convert it to handle. And now I can trigger the onExit method here. So onExit gives me a completable future, right? So I can use all standard completable future functionality. For example, I can do then except, and then let's say I'm just going to print this out. So I'll just do a method reference here, actually. So this prints out the process handle, and the toString method there is actually the PID of the process. So what I'm expecting to happen here, I'm asynchronously starting an external process, so this should return immediately. The process is going to run for 3 seconds, and 3 seconds later, my listener is going to be triggered, and the PID of the now deceased process should be printed. And let's see, you can see that it's asynchronous, not completed, but then 3 seconds later, of course, I see the PID of my process. So very cool piece of functionality there. And of course, you're not restricted to individual processes. You can build whole pipelines in the sense of Unix pipelines, where you can create, like, connect output of a previous process to the input of the next process. So if I wanted, for example, to list all my Java processes and find JShell there, I can just create a new process builder for my favorite command, JPS here, and let's call this JPS. And then I can use grep to find JShell, right? So I can do something like this, and let's call this grep. And then to create the pipeline, I can just use the process builder and its start pipeline method, which takes a list of process builders. So I can take advantage of the new convenience factory methods here and just connect JPS and grep, and let's call this pipeline. You can see that immediately, the process is not completed just because it's asynchronous, but of course it completes very quickly. If I take a look now, obviously it executed successfully and it's all done. So now if I actually wanted to extract the output of this, I can just use the pipeline to get access to the last process in my pipeline, which is index 1, open an input stream to its output, and just print it out. So I'm just going to use transfer to system out, and this is what grep found. So this is actually the process that runs JShell with the given PID. So nice little functionality there. OK, so let's recap. What are some of the best practices that we've seen? Well, remember we now have a ProcessHandle interface, which gives us a clean way of obtaining information about processes. It's a very nice, fluent API. We can take advantage of the convenience methods there, such as PID, info, command, command line. And you can now trigger actions on process termination through the onExit method and the completable future that it returns. You can also connect the old process builder API with the new ProcessHandle API through the toHandle method. In terms of anti-patterns, it's now an anti-pattern to use JMX or external utilities of your operating system to obtain information about running processes from your Java code. Simply because there's now a better way to do this directly with the JDK. Similarly, don't pull in external dependencies for process management unless you need something really specialized. For the simple stuff, an external dependency would just increase the surface your developers need to understand. Just use the JDK. What made the old process builder API hard to use was the fact that even though we could use it to start native processes, there was essentially no functionality to manage them or even obtain information about them, right? So that left developers with implementing their own solutions, which typically were importable, because portability is hard, especially when you're dealing with things that are sort of external to the JVM. So keep portability and completeness of your APIs in mind when you're creating your APIs too. And finally, some interesting patterns that we've seen, so things that we should do. It's a good practice to provide convenience methods in your APIs for commonly used functionality. Well, we've seen it with process info, methods like info, PID, command line. It made the API real pleasant to use. We saw the pattern of using fluent APIs to access nested information. In this case, we didn't have standard getter methods to deal with the process info. The API was more fluent. And as you've probably noticed, I'm a big fan of fluent APIs in general. This API emulated the structure of data by using nested public interfaces to group things, such as the info interface. We saw that that worked pretty nicely and was actually pretty easy to understand too. And we also saw the pattern of providing convenient static factory methods to obtain various instances of ProcessHandle, right? This was much cleaner than overusing constructors for this, because constructors would all have the same name by definition. And with static factory methods, we appropriately named them, and that allows us to easily distinguish between them. There was interesting use of streams here as well. You may have noticed that there were several methods that didn't return collections, which would be more common. They actually returned streams. Now, this is a bit tricky. I wouldn't necessarily recommend this when passing things across API boundaries, because collections are easier to manage than streams, right? Collections, well, basically streams have state, so you can get into situations where your stream is closed, and then you need to handle that. But it is a nice pattern to allow for lazy processing of many things. Also note the pattern for building asynchronous APIs by returning completable future instances. That is the recommended way to do asynchronicity in Java nowadays, since Java 8. That's just how async should be implemented all the time. And we saw that in action with the onExit method. There was also an interesting use of the adapter pattern, too, by providing two methods to do the conversions, such as when going through, from process builder to process handle, we had the toHandle method. Also very nice and useful pattern there. OK, so this brings us to the final part of this talk, and that's the new HTTP2 client from Java 11. So the new HTTP2 client is not just a cleaner alternative to its predecessor, which was, of course, the old HTTP URL connection API, but it actually supports all the cool new things. It supports HTTP2, it supports WebSocket over TLS, server push, proxies, cookies, authentication, basically everything that you would expect from a mature HTTP client. So going back to my JShell here, let's demonstrate this functionality. Now, to demonstrate the functionality of the client, I'm going to need a server. And if there's anything that I've learned from doing live coding at conferences, is that you can never rely on the Wi-Fi there. So I'm going to create my own server here. And I actually really like this example because you can easily create an HTTP server just with the JDK. And I think that's something that many people don't realize. And it isn't even a new API. It's something that has been available for a very long time. So we can just quickly use that. So I'm going to create the simplest possible server here. Okay? The server is going to have a single endpoint. And no matter what kind of request I send to this endpoint, it's going to respond with a fixed string. So very, very simple server here. So let's start by defining the handler for my endpoint. Let's call it a handler. And this takes an HTTP exchange, and it's going to do a quick lambda. Actually, it's going to be a multi-line lambda, so not so quick and not exactly clean, but it will do. So we'll start by defining the string that we want to return, maybe something like this. And let's just call it body here. And now I'm going to set the response headers. So I'm always going to respond with 200. Everything is OK. And the length of my content is going to be the length of my string, just like this. And finally, I can use try with resources. And I'm going to open an output stream. And I will use this output stream to write the string to my response. So let's assign the response body here. And let's just use this output stream to write. I'm going to write my string, and of course this is just a plain output stream, so I need to do this through get bytes, but that is OK. So let's see, and I made a typo somewhere. Sorry? Oh yes, thank you very much. So we have a missing bracket here. OK, that's looking much more reasonable. Let's take another look. Yes, that looks like a good handler here. OK, let's create a server then. HTTP server create. And this needs a port. So let's just give it, let's say 8,000. And I don't need a backlog. And let's call this HS. And now I can finally create my endpoint. Let's say /hello. And I will attach my favorite handler to it. And finally, I should be able to start the server. Now, hopefully, the server is running. But to actually test it, I'm going to need a client. So let's first start by creating a client using the old HTTP URL connection API, just to be able to compare how much better the new API is. So to do this, I will first need a URI pointing to my local server, which is going to be something like HTTP localhost. I think I used 8,000 /hello, and let's call this URI. Then I will need to use the URI and convert it to a URL so that I can open connection on it. And this actually gives me something called URL connection. But that's not what I want. What I want is an HTTP URL connection. So what I need to do here is actually cast it to an HTTP URL connection. And this now is the correct object. So you can see that I'm just starting out with the client, and it's already super unpleasant to use, right? I need to do runtime casting and specify things in a weird way. In fact, if I want to specify the request method on this, for some reason, it's passed as a string. Again, not ideal, but it does work. And finally, to test if it actually works, I can try and obtain the response code. And we can see that it's 200, so this is looking promising. So now, to actually read the response, I'm going to need to open an input stream on my connection, and then sort of standard Java boilerplate, to be able to read from this, I will need to wrap it in an input stream reader, just like this, and wrap this whole thing in a buffered reader. I'm sure everybody was familiar with this, just so that I can call the readline method here, and you can see that it does work. So I have a working HTTP server and a working HTTP client. They can talk to each other, but it was quite painful to get there, right? So now let's try to do the same thing using the new HTTP2 Client API. So the new API is built around 3 main classes. There's HTTP Client, HTTP Request, and HTTP Response. Nice and easy, pretty self-explanatory, right? So I'll start by creating the client. Let's just call a new HTTP client here, and let's call it a client. Then I can construct the request. This is using the builder pattern, so I'll obtain the builder first. Let's give it a URI. I have one from before. Then I can make it as a GET request, nicely as a method here, and just call build, and let's call this request. And now finally, I should be able to use the client to send the request to my server. And this also needs something called body handler here. And in this case, I don't need any special handling. I will just use a built-in handler for this and just tell it to treat everything as string. So I can just do something like this, and let's call this response. And now, to extract the status code, I just call status code. To extract the body of the response, I just call body. And everything works nice and easy. In fact, this client is also very flexible. For example, if I wanted to make this asynchronous, all I need to change is this send to send async here, which now, of course, returns completable future. Let's call it response. So now I can use the get method from the future interface to extract the body, and nice and easy asynchronous HTTP client again, and very, very convenient to use. So let's recap here. What made the new API pleasant to use was how clearly it was organized, right? Particularly in comparison with the old HTTP URL connection API. We had 3 main classes: HTTP client, HTTP request, HTTP response. They're all pretty self-explanatory. Don't use HTTP URL connection. It is not fun. Use the new API client instead. It's very versatile, flexible, and clean. And in general, if there's good functionality available in the JDK, as is the case with the HTTP client now, you should prefer it to external libraries. You're minimizing the surface of what people working on your code need to understand. What are some of the anti-patterns that we've seen? Using HTTP URL connection directly. You should use the new client now, of course, but even if you can't, for whatever reason, it would be a good practice to use something else, such as a third-party library. Apache HTTP client is a very popular one. Inconsistent capitalization is a problem. I always find it hard to remember that URL should be capitalized, but other things like HTTP prefix in the same name shouldn't, right? Always be consistent when it comes to capitalization, especially when you're dealing with abbreviations. A convention in Java is to use sort of strict camel case. So even with abbreviations, you would have like uppercase U and lowercase RL in the case of URL. Developers like to generalize things, but overly abstract and general APIs can be very unpleasant to use. Like, why do I have to deal with URL connection when everybody uses HTTP and just wants an HTTP URL connection? It's a bit tricky with the old URL connection API, basically because it's very old. It actually predates HTTP 1.1. So simply put, HTTP has evolved, and the old Java API is now too abstract partially as a result of that. But the point still stands. One thing you should always strive for when designing APIs is a clear conceptual model that allows the client to predict the effects of their actions. That's one of the big issues with the old URL API, right? Because URL is so generic, it doesn't have a clear conceptual model. At minimum, it mixes two things, right? It provides an abstraction of an address, and it provides an abstraction of a client reading and writing to that address. Those should be two separate things, and they are with the new API. Remember how when we called open connection, it gave us a URL connection object, but we immediately had to cast it to an HTTP URL connection. Having to perform such a cast to obtain a useful instance, that's a big no. And URL connection is actually an abstract class, so you basically always need to cast it. And you're risking runtime errors, of course. That might have made sense in the early days of HTTP, but most of these other protocols that we're trying to support with this URL connection are now dead, right? And HTTP is by far the most widely used protocol. So it would have been much better, if nothing else, to just have at least a method to receive an instance of directly that. Using strings where methods or enums would be more practical is also an anti-pattern. Compare how we set the request method in the old API that was passed as a string versus in the new API that was just a method. It was just better. Again, perhaps that's the cost of the generalization of the API in the past. IO boilerplate, also not good. Just remember how, just to read a line from the connection, I had to obtain an input stream from the connection, wrap it in an input stream reader, wrap it in a buffered reader. Not fun to use. Speaking of IO, mandatory blocking IO is also a problem nowadays. The old API works in blocking mode only, so one thread per request response, which was an acceptable practice when it was introduced, but could be considered an anti-pattern today. And probably the biggest issues of them all, side effects and hidden assumptions. Avoid this at any cost in your APIs. So what I mean by side effects is essentially you want the API to do what it says it does, right? Otherwise, things get very confusing for the client and us as developers. For example, if you have a getter, you just expect it to read something. You don't expect it to write something or change the state in any way. But that's, in fact, exactly what the old API does. There are many, many examples of this in this particular API, but the really painful one is the getInputStream method on HTTP URL connection. We saw that it had the side effect of actually writing, actually sending the request to the server. Example of hidden assumptions. With the old API, it's, for example, also illegal to set a request property after obtaining an input stream. But that's unclear from the Java doc. So there are hidden assumptions like that, which make the API actually really hard to use. And what makes this even worse is inconsistent behavior across APIs. Java has a socket class, for example, which is actually what the URL connection uses sort of behind the scenes. And confusingly, they both have getOutputStream and getInputStream methods, but they behave very differently. For example, the socket methods don't suffer from any side effects. So basically, if you're coming from the socket background and you're familiar with the socket API, you would be even more surprised by how URL connection works, or doesn't work, rather. As for some patterns that are nice in the new API, note the clear separation of concepts. We had the separate class for the client request response that made the API very pleasant to use. Note the use of the builder pattern all over the place. That's also very clean. And using completable future to do async. Like we said in connection with the process API, this is the way to do async in Java. You may have also noticed that the new API really pays a lot of attention to naming things, right? Everything was clearly named. You look at the name of a method or a class, and you know what it's about. No need to read the Java doc. That's very different from the old HTTP URL connection API. You're lost without the Java doc there. Also notice that, similar to the ProcessHandle API we saw before, the new HTTP client also heavily leverages the pattern of providing convenience methods to access common things, also in a fluent way. That also makes it very easy to use. And that's it from me. If you have any questions, I'll be around after the talk. I think I've exhausted all the time we had available. And otherwise, thank you, and enjoy the rest of the conference.